So, in our previous video, we left off talking about lines cut by transversal. And so, this property, angles and parallel lines property, says that if any two distinct coplanar lines are cut by transversal, then a pair of corresponding angles, alternate interior angles, or alternate exterior angles are congruent if and only if, that's a key phrase, the lines are parallel. So that's what we just got through talking about in the previous video. It's kind of where we stopped, saying that if two lines are parallel, so let's use this example, and they're cut by a transversal, then corresponding angles are congruent, vertical angles are congruent, and alternate exterior angles are congruent. And so if all of those are congruent, then that means these others also are congruent because they're corresponding in alternate interior and alternate exterior and vertical. And so you've got all of these different angles, and they all have similar angle measurements. And so what we're going to look at in the next few slides is going to kind of focus on this idea of being able to find angle measurements based off of some of these properties. And so when we talk about the angles inside a triangle, the sum of the measures of the angles inside a triangle have to be equal to 180 degrees. Now, later we're going to talk about how we know that, how to find that, depending on the type of polynomial that we have. But right now we're going to talk about triangles. And so if you were to take this triangle and extend this line L across the top where it touches the very top of that of that triangle, and then you were to extend the bottom half, the line that goes through AC, and extend that, then what you've done is you've actually developed two sets of transversals where this is a transversal and then this one is a transversal. And so some of our angle measurements that we've talked about, they work here. So if you look at this blue line and think about its transversal, well, the alternate interior angles would be this angle and this angle, and then this bigger angle and this bigger angle. Well, we're talking about the measures of the angles inside the triangle. Well, angle 3 is an alternate interior to this angle. And that should be pretty easy for us to see, I hope. It's on the inside of the transversal. They're on opposite sides or alternate sides of the transversal. And then the same thing is true with the one in red, the transversal I've marked in red, where angle 1 and this angle out here are also alternate interior angles. And so their angle measurements must be the same. Well, we know that this full rotation is 180 degrees. From one side all the way around to the other, that full half turn, half rotation. And so when we talk about this, these angle measurements, well, based off of the fact that angle 1 is an alternate interior and angle 3 is an alternate interior, and we already know angle 2 combined with angles 1 and 3 had to be that 180 here at the top, then it must mean that angles 1, 3, and 2 in the triangle also add to be 180 degrees. And so that's something that's really important moving forward, especially as we deal with triangles, is understanding that the angle measurements inside a triangle have to be equal to 180 degrees. So let's look at an example here where we use this idea of alternate interior, alternate exterior angles. So the question says, in the framework for a tire jack, if you've never changed a tire or used a tire jack like this, you can probably go look in your vehicle, and there's probably one that looks similar to this. I had to do this right before we got out for spring break on my truck. And the tire jack looks exactly like this. And so it says that it is in the shape of a parallelogram, and you can see that shape where parallelogram ABCD, which is this whole figure, this quadrilateral. And it says if the measure of angle ADC, so that's going to be this angle, if that angle is 50 degrees, we want to find the other angle measurements of this parallelogram. Now, because it is a parallelogram, this line and this line are parallel. This line and this line are parallel. So, based off of that, if the angle that we have is 50 degrees, then this angle is an alternate interior angle to it, and so it also must be 50 degrees. Well, that means that angle 4, which is a vertical angle, also must be 50 degrees. Which also means that angle 2, which is an alternate interior with this line as your transversal, because again, all the lines, all the sets are parallel, and so each of these form transversals. And so if angle 4 is 50 degrees, then angle 2 has to also be 50 degrees. And if angle 4 is 50 degrees, then angle 1 has to be 180 minus 50, which is 130. And if it's 130, then this angle out here, where this B is also 130. And it's corresponding to angle 3, so angle 3 must also be 130. And so because we know about alternate interior, corresponding, and vertical angles, we can identify the measure of each of these. So let's write some of this out. So the measure of angle 1, we just said, is 130 degrees. And the measure of angle 2, we said, is 50 degrees. And the measure of angle 3 is also 130 degrees. And then the measure of angle 4, which was one of the first ones we found, is 50 degrees. And so when we say the measure of angle whatever, we use this lowercase m and then an angle sign, and then we name the number, name the angle. So if it's named with a number like these are, it could be named with 3 letters. It could even be named with just 1 letter if there's only one angle at a vertex. So be aware of that. So we could call an angle, for example, angle ABC, where B is the vertex. If that's the only angle at that vertex, we could call it angle B. Or if we have it numbered like we do here, then we could call it, not the measure, we could call it angle 1 or 2 or 3 or whatever. So that would be some ways that we would name angles. In this case, we've named it with numbers. If you have any questions about that one, please let me know. So let's look at this one. It says in the figure, line M and line N are parallel. So this symbol means parallel. And K is a transversal. Now, because M and N are parallel, all those alternate interior, corresponding, vertical, they're all congruent. And so the question is, explain why the measure of angle 1 plus the measure of angle 2 has to be 180 degrees. All right, so measure of angle 1, measure of angle 2, the ones that are marked, why are they equal to 180 degrees? Well, there can be a number of ways for us to figure this out. So really the easiest thing is to understand that if angle 2 plus angle 3, those measures, let's put an M there, the measure of angle 2 plus the measure of angle 3 has to be 180 degrees because they're supplementary. Okay, so that means that we know the measure of angle 3. And then the measure of angle 3 has to be equal to the measure of angle 1 because they are corresponding. And so if that's the case, if angle 1 and angle 3 are corresponding, then that means that the measure of angle 3 and the measure of angle 1 can be substituted for each other. And so if you take this measure of angle 1 and you substitute it there, then the measure of angle 2 plus the measure of angle 3 has to be equal, I'm sorry, the measure of angle 1, not 3. Measure of angle 1. So the measure of angle 2 plus the measure of angle 1 has to be equal to 180 degrees. Again, it's because we have the supplementary angles, which means they're equal to 180, and then 3 and 1 being corresponding, they have to be equal measurements. And so because of that, 1 and 2 must be also supplementary. Now, that's going to be beneficial to us as we continue to talk about lines cut by transversals, to understand that those interior angles that are on the same side, so not alternate interior, but